Let's think of a modern day watch. It runs on a battery and shows you the time using a display. 3 parts of the display update every second to show you the time at that instant. The seconds and the minutes and the hours. They all follow a certain set of rules, like the second portion will return to 0 after 60 seconds, the minute portion after 60 minutes, and the hour portion after 24 hours. Same with, let's say, a washing machine. It follows a set of rules or instructions like releasing a certain amount of water, running for a specific amount of time, running a certain number of cycles, and so on. Both of these are embedded systems. Embedded systems have been defined in books in a number of ways, but they all follow the same basic principle that programming a computer is embedded to control hardware for mostly specific reasons. The watch and the washing machine we saw before are examples of embedded systems. In contrast to your laptop, which serves a more general purpose, even though it contains hardware that embedded systems would have. Unlike a full-blown computer, embedded systems are usually small in size and not that powerful, since they don't have to be used in scenarios where you need powerful stuff. Embedded systems are usually designed with a few constraints in mind, like power consumption, processor speed, and size. This allows the system to be small and affordable. One of the very first recognizably modern embedded systems was a computer developed in 1965 by Charles Stark Draper at the MIT Instrumentation Laboratory. It was using the Apollo program to provide computational electronic interfaces for guidance, navigation, and control of spacecraft. Since then, the cost of these embedded systems has been decreasing and the functionality has been increasing along with processor speed. For example, the Intel released their Intel 4004 chip, which was a microprocessor meant for calculators and other smaller devices. The microprocessor required external systems like memory and external support chips, but all of these put together formed one embedded system. These are the hardware components of an embedded system, of which the most basic ones are the processor, the memory, and the I/O, or the input and output interface. The memory, of course, stores data. The I/O is a way to communicate with the user to get certain outputs. Commonly, you would see a graphical user interface, or a GUI, or as I like to call it, GUI. On the input side, that's what you will see, GUI. And maybe some mechanism on the output, like the buttons and display on an ATM machine on the input side and some sweet cash on the output. Let's discuss a few terms that you'll probably hear about when you're learning about embedded systems. RTOS, or Real-Time Operating System. This is sort of the software thing that just controls everything. It's part of the brain, part of the microprocessor. Microcontrollers and microprocessors. These would be considered the brain of the whole system. The difference between the two is that microcontrollers usually have memory and input-output devices embedded into the same chip, but a microprocessor is just a microprocessor and usually takes external outputs from memory and for support chips. GPP, or General Purpose Processor, which has no specific application, you can just program it to do anything you want. ASIP, Application Specific Instruction Set Processor. Basically, it has a specific purpose and you can't change that. Technology has come a long way. Microprocessors have become faster and smaller and more affordable. I/O is now faster with USB 3 and USB 4 on the way. And now, since open source is a thing, everything's available online. You can build whatever you want and design things very easily. Even a CPU is now open source. Of course, for our students, the most useful open source thing is Arduino. It's a godsend. Or a Raspberry Pi, or a Z-board, or the 100 other things. We're inside Bennett, we had a workshop recently on IoT where they taught us how to use Arduinos and build robots using sensors. I didn't attend it.
Baby, drop that ass for it crash. The sky's falling, baby, drop that ass for it crash. The sky's falling, baby, drop that ass for it crash. The sky's falling, baby, falling, baby, falling.